Happy New Year. Hello, everyone. Welcome to CIBSE Intelligent Building Group seminar. Today, we're very fortunate to have Professor Phil presenting his research on bio-regenerative building design. Just a little background for Dr. Phil. Dr. Phil is a consulting engineer specializing in energy and sustainability, working in Toronto, Canada. Phil has several professional designations, including lead accredited professionals, qualified sustainable building advisor, certified energy manager, living future accreditations, and certified building commissioning professionals. His work is around energy efficiency and sustainable building design. And this presentation is based on a recent research grant Phil obtained from National Science and Engineering Research Council using Biophilic Design to improve mental health and the productivity of people at home. Okay, now the screen is yours, Phil.
Thank you, Yan. Good morning. This is Phil, and Happy New Year. And I'm glad that Yan gave me this opportunity to share with you my really deep passion and conviction how we should design buildings, not just for today and really for our future generations. So I'm going to share my slides. So the title of today's presentation is Bio-regenerative building design. It's very specific how we can design buildings provide indoor ecosystem services to contribute to the sustainable development goals. I will talk about what I mean by bio-regenerative. I will talk about why we care about ecosystem services. How does ecosystem services relate to buildings? Why it's so important is that we need to provide ecosystem services through building design and in order to contribute to sustainable development goals. By the way, all my presentation today is from I consolidate from around 10 hours of lecture, right? So I'm sorry, I may have to rush in some the slides. So, but feel free that we can talk after the presentation if you have any questions, right? So, the way that I look at the global challenges facing humanity today and tomorrow, four things: climate change, natural resource depletion, health risk, and social inequality. One of my biggest concern today, you understand right now this world, we focus on climate change, right? Yes, and we focus on carbon. Don't get me wrong, carbon the mitigation reduction is very, very important. But I don't think just fixing carbon will provide a world that our future generations can survive. Because we are facing four challenges, not just carbon, climate change, natural resource depletion, health risk, and social inequality. So in order to mitigate these challenges, I think the built environment shall, one, yes, reduce carbon footprint, but this is not the only item. We also have to minimize the resources consumption. The built environment shall be conducive to occupants' health and contribute to the sustainable development goals. Okay, these are the four things how we can mitigate climate change, resource depletion, health, and social inequality. In year 2000, United Nations, they conducted an assessment called the Millennium Ecosystem Assessment. This assessment was completed in 2005. Then you may ask, hey, Phil, too long ago. Yes, but the implication is huge. So what is this assessment? Well, the objective of this assessment is to look at how the ecosystem services, can affect human well-being. So they want to come up with some scientific basis for action in order to restore, to conserve, and to use the ecosystem very sustainably. Okay, in order for the purpose of contribution to human well-being. So what are ecosystem services? So ecosystem services are the many benefits, services to human provided by the natural environment, And of course, in order for the natural ecosystems be able to provide us those beneficial things, the ecosystem must be healthy. So we classify ecosystem services into 4 categories: provisioning, regulating, cultural, and supporting. So as you can see, provisioning means products directly from the ecosystem. Regulating is how does these services regulate the environment. So sort of the regulating will of how does these ecosystem services help to produce the products, the provisioning. Cultural, so is more about the non-material benefits to humankind. And I think this is really big, especially when we look at mental health. It's a big thing, okay, which is one part of the ecosystem services. And then lastly, it is the supporting. Okay, supporting is the foundation of provisioning, regulating, and cultural. Okay, so these are the 4 big categories of ecosystem services. So UN from the research. Oh, by the way, so if you look at these 4 challenges, you can find the solution in all these ecosystem services. Reduce carbon footprint, minimize resources consumption, conducive to occupants' health, and contribute to sustainable development goals. All the ecosystem services will be able to satisfy how to deal with these 4 challenges. So I try to link ecosystem services in our global challenges. After the Millennium Assessment, they come up with 2 publications. Okay, they talk about how ecosystems and human well-being. So ecosystems and human well-being is really, really closely related. So after the assessment, they they identify problem. Yeah, so they know that climate change is there. They know that energy is something that they have to deal with. But they also identify something new. By the way, this is 2005, 18 years ago. Okay, 18 years ago, United Nations already identified one of through this assessment is the degradation of ecosystems and their functions. Now they pick 24 ecosystem services. There are a lot of ecosystem services, of course, in nature, right? So they picked 24. Out of the 24, 15 have been degraded. So you can see 18 years ago, out of the 24 ecosystem services that picked by UN for assessment, 15 were being damaged. So they have 4 main findings. I'm not going to go through in details, but basically for the first 50 years from 1950 and to 2000, we humankind use a lot of resources. Okay, so because of that, there is some irreversible loss in the diversity of life on Earth. Right? Okay. And there's no question, so we humankind, we require ecosystem services. Right? We need resources to survive. Right? We need housing, we need food, no question, right? So there is no question that for the first from 1950 to 2000, they improve, the economic development, the well-being of people. But at the same time, during those 50 years, we have minimize, we diminish some of the benefits for future generations. So, and they look at the next 50 years, 2000 to 2050, they believe this degradation of ecosystem services will grow very significant, worse. Well, they look at what can they do. Yes, they said, to reverse that is possible, but it will involve in some significant changes in policies, institutions, and practices, which are not currently underway. So they look at is a really grim picture, okay? All these services that are being damaged, okay? And we, humankind, relies on those services to survive. But they do. And they did provide one of the options. One way to reduce or possibly reverse the negative environmental impact of the built environment could be to create new developments or redesign existing buildings and urban areas so that they provide or support ecosystem services. UN said, is it possible? But why can the new build and existing buildings, can they provide local ecosystem services? Because if they can do that, we can reduce, rely on the natural ecosystem services. And then the natural ecosystem, they can be regenerated. It can be replenished. Think about if the ecosystem services keep on dropping and the population keep on growing, the gap is between really, really big. And then a lot of people, 70% of the people in the world, they are mostly underprivileged. The social inequality will really getting bigger and bigger a gap. So UN said, why not build an environment, provide ecosystem services? Please bear in mind, carbon is just one of the ecosystem services. We cannot just look at carbon. We cannot. Okay, think about it. If we can solve the carbon problem, but the entire ecosystem being depleted, damaged, and unhealthy, humankind cannot survive anyway. So it's not just a carbon problem. So we are looking at from our regular reclamation to rehabilitation to all the way to natural regeneration. We must provide ecosystem services in order that the natural one has the time, has the opportunities to be regenerated. Probably we all know about the late Steve Jobs. He had a visionary statement. He said, I think the biggest innovations of the 21st century will be at the intersection of biology and technology. A new era is beginning. To me, it's a huge visionary statement from the late Steve Jobs. The biggest innovation of the 21st century will be at the intersection of biology and technology. Now, from this statement, I come up with my understanding. That becomes my mission. Okay, I make it as my missional statement. I think the biggest innovation and design of the 21st century is at the intersection of natural science, nature, and engineering. This is how I understand, how I interpret, how I apply Jobs' visionary statement. Intersection of natural science means nature and engineering. Well, I have a lot of video, and I'm not going to show them yet because I'm not sure how much time that I can have, because of the kind of materials that I'm going to present. So I'm not going to. So nature, right? So it's intersection of natural science, means nature and engineering. Nature design has been tested for 3.8 billion years. They are sustainable and harmonized with the ecosystems. They have been tested, trial and error. And then this is how they survive. Survival of the fittest. They survive. And from the survival, we can see they are resilient. They create symbiotic relationships. So, you know what, whatever disturbance coming, they have a way to work with the ecosystem and not on their own. Okay, nature work with their own ecosystems to come up with conditions so nature can survive. Okay, 3.8 billion years. Can we see that kind of knowledge, wisdom behind? If you look at how does nature operate and survive, can you see all this? You remember our 4 challenges? All the answers here. If we can just look at how nature operates and survive, we find all the answers of our 4 big challenges, from carbon to resources, okay, to health, to social inequality. Here, right there. After 3.8 billion years of operation and survival, they come up with this is how nature works. So why not learn from nature, design our building accordingly to deal with our 4 challenges. So combining natural science and engineering, we come up with what we call multidisciplinary nature-inspired design. So this nature-inspired is the word, when I use the word bio, when I say bio means nature-inspired. So it's a multidisciplinary subject. So all disciplines of engineering and together with natural science, we get together, we design for the future of the world. So the first nature-inspired design or bio-design is to reconnect with nature design. So the other technical term is biophilic design. Okay, is reconnect with nature, right? So it's biophilic. I'm not going to go through this topic. Okay, so but it's biophilic means it is a combination of biology and psychology. Okay, because we humankind when we born, we have a natural connection with nature. Okay, so biophilic design or biophilia is to study how to reconnect people with the natural systems. Please bear in mind, it's a reconnection. This is not a new connection. It's a reconnection because we all born with somehow like a connection with nature. So when we do biophilic design, so the environment will provide people to live and work in a healthy places and with less stress and greater overall health and well-being. The second bio design is learn from natural design, learn from nature. Okay, the water, materials, energy, learn from nature is what we call biomimetic design. Biomimicry. Biomimicry is how we copy from nature, how we imitate nature. Okay, and then biomimetic design is how we copy nature and then use and adapt the biological principles into modern technology and to address variety of human needs. Okay, so you can see a lot of biomimetic design. The A380, the largest plane in the world. Okay, when they came out, they released a paper. The way that they designed the wing is from the eagle wing. Okay, so a lot, huge amount of applications. Today a lot, thousands. All right. So second is biomimetic design. The third, biodesign, is how do we utilize. One is to reconnect with nature. Two is to copy nature. Three is how we make use of the natural resources. It's what we call bio-synergistic design. So you can see water, soil, worms, plants, air, sunlight. Okay. So biosynergy is you combine two things, it come up with something better, has a greater benefit than each one operate individually. Means 1 + 1 is 3. Is biosynergy. Is the third kind of nature-inspired design. So one thing that that I use a lot is what we call the facultative mutualism. Means we put things together, A and B, but the survival of A and B, it doesn't rely on each other. Okay, independently they can survive. Okay, so A survive is not because of B there. B survive is not because of A there. They can survive independently, right? But when they get together, they come up with something. 1 + 1 is 3. So this is what we mean by biosynergistic design. We see a lot of applications, right? Especially when you look at our human body, the natural systems, the microbes. A lot of these they form synergies. Next, I like to talk about, remember that my topic is bio-regenerative. But bio I talk about is the nature-inspired, right? So regenerative, what we mean by regenerative. Now, many people ask the differences between regenerative design and sustainable design. To make it really, really short, okay? One, sustainable design, they talk about things that will not do harm to the natural environment, zero harm. But sustainable design cannot create something new, cannot regenerate anything. But the best sustainable design is zero harm. Oh, don't get me wrong, it's very important. If everybody can do zero harm today in the building industry, it will be a great, great achievement. Okay, but to talk about the differences, sustainable cannot generate anything new. Regenerative, well, please bear in mind, regenerative design must build on sustainability practices. We cannot do something we call regenerative, but it's not sustainable. This is not regenerative. Regenerative design must start with a sustainable design, but it will not stop there because it has to increase the ecosystem health. So sustainable design basically is to provide the fundamental human needs. Regenerative design is planned for the future for the coexistence of human and other species nature. So regenerative is look at the coexistence of human and nature. So when we measure success, sustainable design, when we measure success, is by the performance of building and development. But regenerative design, we look at the improvement, not just the building and the development, and also improvement in the health of human and the ecosystem as a whole. So really brief, okay, just to give you the precise definition of regenerative and sustainable. Sustainable, no harm, okay, but cannot regenerate, cannot make something new, okay, cannot restore. Regenerative must based on sustainable, all right, and then it will regenerate. Okay, so we look at regenerative design. How does the design benefit humankind as well as the ecosystem as a whole? Okay, so this is the main difference between regenerative and sustainable design. So we have to move. We have to move from the human-centric anthropocentric okay, to a biocentric design. The different building challenge is really close to the biocentric. Okay, I would say they in fact they're overlapping. All right, when you look at the different building challenge, need is still under a sustainable design. All right. In the meantime, I know that when you look at the future of LEED, they look at some kind of regenerative design, but not yet. So we have to move away from the human-centric to biocentric. Biocentric means regenerative design. So that's why we need a bio-regenerative building design. So means learn from nature. Okay, biophilic, biomimetic, bio-synergistic, and then the building will create something new, will restore the natural ecosystem surfaces. And from there, we will come up with bio-regenerative engineered ecosystems. So in fact, we create engineered ecosystems here. You can say that they are artificial, and they're really not. They're real, okay? Because we use natural elements, all right? But just they are recreate. From the engineered ecosystems, the building will have the ecosystem services. I think that is the key to deal with the 4 challenges. Carbon is one of them, but carbon is not everything. We cannot just deal with carbon. We have our health risk. We have social inequality. We have natural resources depletion. Climate change is one of them. All 4, they're all very significant, right? Look at the pandemic affecting everything, and of course, climate change make it worse. If there's no climate change, the pandemic, maybe we can get by easier. But with climate change, oh boy, it's terrible. So, but what I'm saying is climate change is not everything. We have to look at all 4 challenges. So we cannot just look at carbon. It has to be the entire, how do we make building to create some kind of ecosystem services? And of course, different buildings, they provide different ecosystem services, right? Some building will provide ABC, and some will provide DEF, right? But buildings, new or existing, must provide ecosystem services. So from the ecosystem services, we'll be able to reduce carbon footprint, to minimize resources consumption, to conducive to occupants' health, and provide sustainable development goals. Again, not every building ecosystem services can provide everything. Some may focus in reduce carbon footprint. Some may do minimize resources consumption. Some may have health and minimize resources. It depends. But if only every building, new or existing, can provide ecosystem services, then we'll be able to deal with the global challenges. So the engineered ecosystems is something that we create. It depends on project, right? So you can think about we learn from nature, right? So we create something inside the buildings in order for the building to provide ecosystem services. All right. So because they're inside building, there are pros and cons. So something that we cannot use outside because this is inside, right? But because inside is a more controllable environment, then it's possible that we can expedite the benefits. Because in the outside environment, because you cannot control, especially this crazy climate change, the extreme weather, you cannot control. But when you're inside, you can do a better control. So the engineered ecosystem is possibly can behave better than the exterior one, the natural one. Again, in order to do the sustainable building design, in order to do regenerative building design, we must base on a sustainable building design first. I have my opinion. Okay, this is my opinion. Okay, when I design buildings here, in terms of the the envelope materials, okay, I prefer ICF and the zip structure insulated panel shell, and then use the passive house as the passive home standard. All right, as the envelope, mainly for thermal bridging challenge, right? And then the other attributes I will use neat gold, and I believe in UK, in Europe, is not neat, is not the major one, is the BREEAM, right? So I think BREEAM excellent is very similar to neat gold standard. Okay, so means before I do regenerative, I want the building to make sure they are sustainable first. My way of design sustainable building is to use this kind of shell using the passive house standard for the envelope, and then the internal attributes, the green attributes will be in the neat gold or BREEAM excellent standard. Okay, this is the foundation. And then in my work, I touch on 5 areas: food, well-being, energy, air, and carbon. And some of them, they are more advanced, some are less, some at the beginning, so it depends on how many projects that I have, students, funding, many things, right? So, and applications, okay? We create pilot project and commercial projects, right? So I'm going to go through that. What time is it now? How much time I have? Let me see. Oh, okay, 11:30 now. So I have around 15 minutes. So I want to leave some time, right? That we can talk. Okay. So because is how much video that I can show you. Okay, I'm going through these 5 areas now. Okay. What work do I do? How do I create ecosystem services? And of course, again, different building, they provide different ecosystem services, right? We don't need every building to provide all ecosystem services, and it is not doable. But as long as every building we provide some ecosystem services, I think this is the way that we deal with these 4 challenges. Next, my design principle is nature is our mentor and model. Community is not a forest. Buildings are the trees. This is my overall design principle. In fact, I will show you briefly one of my design it doesn't look like a tree, but the essence of the design is like a tree. It's not a building, but it's a standalone structure, right? So I will show you a little bit, so. Let's look at like a few research projects, right? So the first one, food. My research is based on how does nature grow organic food with natural inputs. This is my question to nature. So when I look at food ecosystem, right? So I look at, okay, what is my problem? Okay, my problem is how to grow food, healthy food, how to deal with food sovereignty, how? Okay, so I go to nature. Hey, nature, tell me, teach me, give me a model. How do you grow organic food with natural inputs? Doing these ecosystem services, the food ecosystem services, I can contribute to these 4 sustainable development goals. So the system that we come up with is we focus on a community-based food system, right? That we address food sovereignty. My definition of food sovereignty is food diversity, food safety, and food security. Okay, so we use 3 methods. Many people indoor farming doing hydroponics. No, we do aquaponics. Is different, okay? So our aquaponics is organic, okay? It's certified organic in Canada here, okay? And hydroponics and soil. Because all 3 methods, they have their own benefits. All right, so it's because of all three combined, we are able to provide food diversity, food safety, and food security. Okay, I'm not going through all the details. So and then I will show you the pilot project later. The second research topic to me is the well-being ecosystem services. How does nature nurture human well-being? How we know that there's a connection there? How does nature do that? So, and doing that, I can contribute to these sustainable development goals. We focus on nature therapy. In Canada, I'm not sure in UK. In Canada, US, Australia, nature therapy is now is a medical prescription now. So medical doctor can prescribe nature therapy. Let's say you can go to the park Monday, Wednesday, Friday, 7 to 7:30 to take a walk. It can be a prescription. Nature therapy is no longer an alternative medicine. It is a mainstream medicine here in North America. All right. So this is how, in our research in well-being ecosystem services, we make use of nature therapy. Third one, energy ecosystem services. What are the functions of trees in nature? Now that is our question. So you may ask, how does trees and energy related? They are very much related. When I ask this question, okay, providing energy ecosystem services, I contribute to these sustainable development goals. So we focus on DC. Okay, we right now is when we do research project, right? They are focused on ACDC, right? Because totally DC house is not here yet. Okay, it's just in experimental stage. Okay, but we focus on DC and communication. Look at how trees work. If you look at this picture, I hope you can get some insight. How does trees work in nature? They work together like when we look at energy. I think the biggest thing in energy is no longer energy efficiency. Well, don't get me wrong, energy efficiency is very important, but it's no longer, to me, is the biggest topic. The biggest topic to me for energy ecosystem services is resilience. How we provide a resilient energy system. If every building, they have a resilient energy system and they can communicate, you make the entire community a very resilient energy ecosystem services like trees. And next, we look at clean air. Okay, so how does nature purify air? Is as part of our air ecosystem services research work. Basically, we look at how nature works. They use three methods. Okay, absorption, adsorption, and biodegradation. Okay, so the way that we in our research, we use plant for the absorption. We use biochar for the adsorption because of the cat ion. And use microbes for degradation. So we come up with some prototype. I call this prototype as an urban tree. So far when we tested with formaldehyde, yes, it's very good result. Okay, this one using natural thing like plants, biochar, and microbes that reduce a lot of formaldehyde that we inject. You understand? Formaldehyde is the most significant VOC, right? A volatile organic compound. In the air, right? For air pollution. And lastly, when we look at the carbon ecosystem services, we look at how does nature perform carbon sequestration. How does nature do that? So and then in our research work, We use and biochar is the product that we use a lot, okay, in many areas, from the indoor farm to our indoor wetland. Everywhere we use biochar, because one of the properties of biochar is to retain nutrients. So the carbon capture go into the biochar through the pyrolysis, right? So and then going through our process, at the end, these used biochar, they all filled with nutrients. They are fertilizer. We grind it down. We put it out to the soil, and the carbon stay there. So this is how we, in our research work, and also we look at how we use the biochar, and we come up with new scenarios. All right, so let's look at let me see how much time I have. Commercial projects. This is it's an off-grid food shed for Cedar Brampton. We build a tree. This tree is not, we don't grow it. We build it, okay, to feed your community year round. This is a solar PV off-grid food shed in an urban environment. Now, the design of this food shed is absolutely like a tree. Okay, I don't have time to go through all the features. It doesn't look like a tree, but when you look at, there are 10 features. How does a tree work? And it's the same thing that how does this food shed work? All right. Okay, I'm sorry, I cannot show the video for now. These are the counselors at the opening of the food shed. All right. Okay, so and then we have the Country Heritage Park, you know, in Ontario, Canada. So they provide the entire food ecosystem, because they are not just growing vertical food. They also do. One is, you know, this is part of the, we have hydroponics, aquaponics in soil, and they are not just doing regular tilapia. We also have the rainbow trout. They don't have just the adult rainbow trout. They also have the fingerlings and the breeding tank. Is the entire food ecosystem here. Okay, from all the way from breeding to fingerlings, and then they consume the fish, and then we have the fingerlings to replenish the fish system. Okay, so this is the project that is the client, you know, is to help the community, or to provide a lot of the food ecosystem there. Yeah, fingerlings, rainbow trout. Okay, and then we have St. Jamestown Co-op housing. No, okay. So we have the central food system. Okay, and also we put the food shelf into the social housing people's house. Okay, we help them, we train them. Okay, this is from a government grant. All right, so to grow their own food. I don't know if it's the same in UK. In Canada during the pandemic, right? You know, the food bank food capacity is coming down, the donation dropping, but more and more people, they require food bank. How can we, people just go into food bank, but there's not enough food? So we cannot just give fish. We have to teach them how to fish. So and also the way that we do the aquaponics and the soil, they are Canadian or organic certified. Hydroponics, because there's no organic system in Canada yet. Okay, so that's why it's not, but it's all natural. So this is the food shelf. So every apartment, not just every building, every apartment, they can provide their own food ecosystem. And more than that, what we found, when the kids, they go and look at the food ecosystem, sometimes they help to clean it up, nature therapy. The mother told us, the kids calm down. Calm them down. It is nature therapy. It's not just food. All right. So one system, they provide multiple ecosystem services. And then this is the Gibson Center. This is the community center. Okay, so we have the indoor farm there. Okay, so and then I provide a lot of education, and then we have people there. They will come to farm and they harvest. So all right. So it's the community engagement, and then at the same time we also help the food bank, and starting not this month. This month we will harvest every week for the food bank every week. Okay, and then we have the nature room. It is to provide the nature therapy. Okay, so yeah, it is the entire room. We have this is the natural wetland, the entire ecosystem there. All right, so when people walk into the office, they will experience, especially think about winter. Okay, when it's really dark outside, gloomy, you can see nature, you can smell, sometimes you can taste, you can hear the noise, right? So this is nature. And lastly, this is from the former mayor of Seattle, Michael McGinn. We are the first generation to see the effects of climate change, and the last generation who can do anything about it. Okay, so to refuse to use every tool at our disposal in this fight to embrace inaction, we are endorsing suffering, privation, and calamity. I really agree with him. When he said we, is my generation. Well, I don't know about the audience here, right? So if you are over 50, okay, I think you are part of this first generation. Okay, so we really see this extreme weather. If we don't do anything, when we say that I think we all say that we love our kids, right? Oh, my kids is our treasure, right? Do we care about in 2050 when our kids will be around 30, 40, 50s, Do we care about what happened to them? If we say we love our kids, right? Do we care? Again, it's not just carbon. We have 4 challenges: climate change, natural resources depletion, health risk, and also the social inequality. So, thank you. This is the end of my presentation today. I'm sorry to be really rushed. I'm not able to show you any video. I will open up for questions. So I'm going to stop this presentation.
Thank you, Dr. Fang, and many thanks for the participant. And there are already some wonderful questions. Please feel free, everyone. Just type your question here, and Dr. Fang will answer it. The first question is whether it's possible to share the slides you just presented. Okay. So,
yes, I'm gladly to do that. Yes.
Okay. So I'll post the link. The link is CIBSE IBG network, and I can see Dr. Tong Yang is here. Is our communication manager, and she will upload your slide on the website. Okay,
yeah,
thanks.
I will provide the PDF. Yeah. So.
Yeah. Yeah, thanks. And David asked the question, how does Well and FitWell provide these services? I guess this your
yes. The Well and FitWell, one is for more general commercial building. They focus on the health. We know that they focus on health, right? So they are good, So I compare 3 systems: Well, Lead, and Living Building Challenge. Okay, so Well is they really focus on the human health. Great, if every building they are well building, at least they can provide the health ecosystem services. Okay, that is absolutely wonderful. Okay, so
The different focuses, isn't it?
yeah.
Yeah, and we have wonderful question from Sandra Lester. And how does this approach, your approach, how can you help to find a way to select building materials?
Right. Well, I always go back to the 4 challenges, right? The climate change, the natural resources, the health, and the social inequality. So just from those 4, when we look at the climate change, we know at carbon, and of course we know that this many people and we are doing now. You know how we can mitigate carbon contents in our building materials. This one. The natural resources. So how can we minimize or optimize the raw materials that we use? Can we reuse? Right, the 3 hours, right? So I think this is the other one. The other criteria, again based on those 4 challenges. 3, health. So and of course those materials, the VOC contents. Okay, the kind of pollutants. How can how to reduce mold? Okay, so and social inequality. Are those materials easily accessible? Okay, if those materials, it means I'm talking about more about the local materials, right? If they're not easily accessible, then how can they do? How can other people, regular people, they can get access to these materials? So what I mean is, I always use these 4 challenges to guide me. Okay, what kind of ecosystem services that I can do? I think that also apply to materials in when we do buildings.
Yeah, thank you. So we have another question from David. Should we change our diet and not to eat meat to improve the land and the carbon situation?
It to me is a personal preference. All right. So yes, if you can do that, yes, you can reduce methane. Yes, you can reduce carbon, but at the same time, maybe you are, but maybe you are not dealing with other challenges. Yeah, you are dealing with the climate change, that's the carbon side, right? So can we also help to provide other ecosystem services from the other 3 challenges, right? So I think if it is a personal preference, it will help because it addresses the climate change. But I hope that all of us can provide different ecosystem services in more than one area. I think that would be really nice.
Yeah, thank you. They're just the precise, and Sandra said it's brilliant presentation. Thank you very much. And yeah, brilliant situation from Comodity. Michael asked the question: container growing comes with problem. You cannot equate artificial lighting with the sun, also fish. Yeah, it's yeah. How do you?
I agree.
Yeah.
I agree 100%. It's absolutely we cannot replace nature. No way. Okay. There are many things in nature we cannot replace. But at the same time, there are things that we can do. Okay. There are strict regulations in Canada how we do organic food systems. One of the concern is lacking of natural sunlight. Okay, so they are pros and cons. Okay, but there are things that we can do. We just try to use the best of the indoor environment, right? How we can provide ecosystem services. Again, there's no way we can totally replace nature. Natural sunlight is the best, but we are the second best, but at least we can help. Let's say in Toronto, you can only grow 4 months outside, 4 months. But when you do inside, you can do 12 months, right? So there are pros and cons that we have to live with that. I agree with that.
Okay. Yeah. Yes, I'm not sure, Sandra, can you talk? Can you speak? I'm not sure whether you should be, sorry, if you can't, I'll hover with here. Sandra asked a question, basin can re-establish and regenerate ecosystem. The wild beast can help. So whether we should go back to wild food for protein. So put a few questions together so you can answer. And Peter also asked, how do we see this concept integrating with existing your bio-regenerating concept with global exponential growth, economic growth strategy. So whether they're compatible. And Sandra, another question, is this issue with separating the hydroponic system from greenhouses that have soil-based system, whether it's aquaponics or hydroponics?
Well, there are many
Sorry.
questions.
Sorry.
Well, I will see what I can. One is in biomimetic design. We really learn how nature works. Then we apply natural principles, right, to solve our problem. So the more that we can learn, the better. The more that we apply, because nature provides the most resilient and regenerative solutions. I think the ecosystem services. Right now, when we take rainwater or air, they're free. I'm telling you, they're really not free. If you want clean water, if we want clean air, it is not free. So if we can provide ecosystem services, we are helping the whole world, okay, to reduce the health risk. Healthcare cost is huge. It's absolutely huge. If not, talk about it costs human life. Okay, so I think if every building can provide regenerative ecosystem services, it will help the entire world. It makes sense in the economic sense. I think so. All right. Because right now we don't treasure our natural systems. Right now, there are organizations start to make the natural ecosystem system tangible. How much that they cost the wetland? How much when you damage the wetland? How much that you are wasting money? So I think this is it. If we make them tangible, then I think we realize all these ecosystem services that we can provide is worth a lot of money. Or it can save the community, the city, a lot of money.
Okay, thanks, Phil. There's another question. Can you share any technical information? How can you deal with nuts and bolts and design the buildings, and where can find further information?
When you say, I need to qualify this question. Are you talking about when you say design a building? Because there are many things. Are you? The only thing that I mentioned in the slides is that we start with the sustainable one, right? The ICF, the cPanel, the passive house, the need or BM, right? So when you do regenerative one, right? So in many cases of my clients, they focus on some areas. They don't do everything. Okay, their interest. Let's say one of my clients really interested to provide our winter garden. Okay, to provide the nature therapy. This is a condominium, right? So people, when in the wintertime, that they can go in there, right? So and then there are, as I said, there are other projects that they put food system in there. Okay, so the food system will provide nature therapy. So it depends on the context of your question, right? Are you an architect? Are you an engineer? Are you a building developer? Right. So I need to know before I can really help you to give you specific my opinion. I'm sorry about that.
Yeah, it's complicated. Yeah, it said it's architect. Yeah.
Mm-hmm.
Okay. Yeah. Can we here? Can I have a commercial?